Good evening all. I hope we can start right now. The Society of Naval Architect Students, NAS, is a students' body by the students of Department of Ship Technology. We have joined together to witness the fourth episode of series of webinar in association with DOSTAs related to naval architecture and shipbuilding. For the fourth episode, we have Mr. Pramod Chambath. He is the 21st batch alumnus of Department of Ship Technology. He is currently now working as a site manager at Sequest Marine Power Management Limited in Korea. He completed his master's from Chosun University on Ocean Engineering and Naval Architecture. He has also worked in Navigati Designs and Constructions, Western Group SA, Emirates Maritime LLC, Generation Lloyd, Taiwan Maritime Transportation, and also in Samsung Heavy Industries. Now it's my proud privilege to invite the guest of the day, Mr. Pramod Chambath, to lead us to the webinar on the topic Shipbuilding Process, a Korean Way. Please, sir.
Thank you very much. Good evening to all. I see a lot of people have joined. Some people from Cochin Shipyard and some of the seniors. Basically, my intention today is for our department students. So I have simplified my presentation. Also, because of the confidentiality agreement, I am not able to share many things on the slide, but you are always welcome to ask me. You're welcome to stop in between and you can ask me. Of course, there's a Q&A session, but you can, in between, if you want to stop me and ask something, please go ahead. I'll try to share this. Just give me a second.
So it seems that there is some technical issue, so we'll be back right now. I appreciate all your patience.
Sorry for that. The share function was giving me trouble. I try again now. I hope you can see it now.
Yes, sir, it's visible now.
Okay. So what you see on the screen is not very far away. You are using virtual reality. That's a virtual reality headset where you put it on and you can actually go inside the ship and have a look. It's not fiction anymore. These things are in progress in Korea, especially Samsung Shipyard is investing a lot for this, as well as Hyundai as well. So in future, you would be able to see what you are actually seeing on the slide to go using your AV VR glass and then see the ships like that. Anyway, before starting, I just want to have a little bit of interaction with you guys. I would like to at least a few people share with me why you joined ship technology, and what do you think? Why is naval architecture and shipbuilding important? What is the career you're looking for? Can somebody give me some answers, please? Nobody?
So,
why you guys joined Department of Ship Technology? What are you looking for? What is the career you are looking for?
so basically, I thought, basically, I just joined. I'm in second year right now. So basically, 2 years back, I thought that to have a unique career choice, which would stand out, and I think that it also helps to create a job opportunity, and also I believe that 90% of the trade is by ship. So I want to know how this vessels works, and it's always been a wonder for me since childhood.
Actually, I agree it's a unique opportunity, but I don't think it was a very limited opportunity to work. Actually, you can work in a lot of field. You can work in from shipyard, you can work at owner representative, you can work in class, you can start your own company. There are a lot of things we can do. This is, of course, a unique branch for us, but we have a lot of opportunities in our career. So I will start with a little bit about me, where I have been jumping around from one side of the table to another side. So I will tell a little bit about me. I was graduated from the department in 2001, 21st batch. And then initially I was in Goa for some times, and I was a naval architecture lecturer for the marine engineers. It was very interesting time because that actually helped me to refresh all my theory, which we learned. And then I joined Samsung Heavy Industries. So Samsung Heavy Industries is one of the top 3 shipyards in the world. And I joined as their hull structure team as a designer. I worked there for 5 years. And then during that time, we have a collaboration with this university, Chosen University. So any of our students who has already graduated from KUSAT can get a full scholarship on this Chosen University in Korea. I know many of my junior have joined for master's program as well as PhD programs here. It's fully covered. You also get a small stipend if you apply for this. And after that, I thought design is enough. So I went to the owner side or the buyer side, and I worked as a hull supervisor. When they were building ships in the shipyard, I was working as a hull supervisor for various Korean shipyard. Then I got a chance to work with GL, now DNV GL, and then back to DNV. DNV has taken over GL now. So I was working as a GL surveyor just to be on the other side of the table. And then I started a little bit of freelancing, and I worked as a site manager for a few ship owners in Korean shipyards. And then I went back to Samsung. Samsung called me back to work at their project management team, so managing the projects. And then again, after 7 years there, then I decided, okay, it's time for a little bit more freelancing. So I'm back as site manager for Sequest Marine Project Management. So that means in shipbuilding, you have basically 3 sides. Of course, the financial part I am not counting. So what I want to show you is you can work on any site. You can work in the class, you can work in the shipyard, you can work also as an owner representative. And I know many of our seniors and some of our juniors are also working on the operation part. So this is, of course, a unique opportunity for you, but you really have a wide range of opportunities where you can work. So this is not a very narrow job. You always have an option, wide option. Okay, let me come back to my presentation. So this photo is actual photo of Korean shipbuilding industry. Just for people who don't know where Korea is here, and it is very near China, across to China. And of course, there's North Korea, which is more famous than South Korea. So what I'm talking about today is Republic of Korea or South Korea. So if you look at South Korea, you can see this is the southern part of South Korea. So mostly the shipbuilding industry is staggered on this southern part of South Korea. So if we look at the graph, why I was talking about Korean shipbuilding industries. One, I have been in Korea for past 20 years. Number two is, if you look at the graph, when you started the shipbuilding industry, it was always the European and the Japanese. And then slowly, South Korea started catching up from 1970s. And this graph is only up to 2002. So if you look at the graph, you extrapolate to 2020, you can see that China has also started to come up. And Japan has started to go down. So the main shipbuilding activities is currently concentrated in Korea and China. That's why I have selected this Korean shipbuilding industry as an example for showing you how the new building process works. Okay, now in Korea, there are 84 shipyards, 84 shipbuilding companies. And of course, the major five are the most important one. HHI is Hyundai Heavy Industries, the same company that makes Hyundai cars. Daewoo, DSME is Daewoo Shipbuilding and Marine Engineering. This is the same company which makes our Daewoo Mattis cars. And SHI is Samsung Heavy Industries, the same company which just makes the mobile phone. And Hyundai Moppo and Hyundai Samho are part of the Hyundai group. They actually spread around in many areas. So if you look at the map, if you can see Ulsan, it is where Hyundai Heavy Industries. And then if you come to this area where it is marked as Halla, this is the area there where they have this Mippo and Samho. This was basically Halla shipyard long time ago, which they acquired, and now it has become Hyundai shipyards. And there are medium shipyards like STX, Daehan, Hanjin, Sundong, Daesun, etc. And there are so many small shipyards. So these small shipyards, generally, they need not always make the full ship. They can also act as the subcontractors for the major shipyards and the medium and large shipyards. So in Korea, one of the major employer is this shipbuilding industries. And if we look at other part of the world, we always see a blue collar and a white collar, right? Blue collar are people who are working in the production area. White collar are people in the design and office and things like that. Korea is a country where the blue collar people are getting more paid than the white collar people. So that is also due to their high productivity and skill, which we'll come to later. But just as a fact, you can remember, even if you're on a production site, you are getting more money than the guy who is sitting in the office or in the design. Okay, now I have a small video, time-lapse video. This is a Maersk Line container vessel. Just have a look, and we will talk a little bit about it. Yeah, so if you paid a close attention to the video, you might have seen that not only one vessel, but 4 vessels were building at the same time in the dock, and they were launching one vessels and half of other 2 vessels outside, which they call tandem floating, which actually you make 2 big vessels and 2 half vessels behind. So you have about 3 vessels in the dock, 2 and 2 halves. So you save that much time, because in any shipyard, the dock is what is your limitation. The more number of docks you have, the more number of vessels you can make simultaneously. So in order to maximize the dock productivity, they use a kind of system called tandem building, which they build half of the ship and one ship. So 1.5. Sometimes if the dock is wide enough, you can have 2 and 2 halves. Okay, let's come back to the whole shipbuilding process. So, shipbuilding process, if we talk about the process, we should understand that it is a very composite engineering industry. Not only need naval architecture people, they need mechanical, electrical, automation, civil, chemical engineer, architecture. So it's a very composite engineering industry. And it's really labor incentive, and technology and capital is very, very important for this. I will come to these points later. And it's a single global market. What does that mean? That means it's not that there is a market for India, there's a market for Korea, there's a market for Japan. It does not work like that. It's a global market. Anybody can order a ship anywhere in the world. So you are competing with different countries. It's not a localized market. It's always a global market. And other thing is the long lead time from contract to delivery. This is very important, because if you want to go and buy something from a shop, say for a car, if it is not a new car, which has long waiting line, you just go and get the car. You can drive the car back to your home. But in case of shipbuilding industries, it does not happen that way. Why is it important? It is important because if now I see the market, okay, now bulk carriers are boom. So let me go and buy a bulk carrier. Of course, you can go and buy a bulk carrier which is in market as a second-hand vessel. But if you want to do it a new building, there's a long lead time. So by the time the vessel is built, say 2 years, maybe the bulk carrier market has been crashed, and then the tanker market has been up. So this is also a characteristic of this. So what are the fundamentals you need to understand is capital is very, very expensive, and the quality, delivery time, and reasonable price is very important. And it's made to order. Like I said, every vessel is difficult. Even if it's the same VLCC, even if they say use the same and say it is, unless it's a sister vessel, it's all different. And the market is very, very fluctuating. And the first thing, the Greece will smell the market and they start ordering, and then others will follow. Then it will be overcrowding of the market, and then that kind of vessel, how to say, the boom will go down. So it's a very, very fluctuating market, and competitiveness can be acquired through productivity, that is basically skilled labor. And most important is the last one, associated industries. So many people ask me many times, why in India you cannot build ships like this? You have a very good weather compared to here. Here we have snow and very cold and very hot. And why you can build in India where the temperature is almost constant? The main problem is we don't have associated industries. We don't have other industries to support the shipyards. So we have to import everything from outside. which actually again increases the cost for us, then we lose our competitiveness. Okay, now to understand the whole shipbuilding industry, we will have a look at the upstream and downstream. The upstream and downstream used in a different way for offshore. So just the offshore guys, please pardon me, I'm using your words here. So upstream of shipbuilding industries it could be shipping, yeah, that could be energy, it could be fisheries, tourism, defense. And downstream would be all the equipment plants, the paint manufacturer, the electrical equipment, steel, etc. And also very important is the related industries, IT, robotics, furniture, computer software, and very, very important is the financing. So this is where the shipbuilding industry. So shipbuilding industry is very volatile. Any variation in either upstream or downstream can directly affect our industry. So it's like a trade, it's a stock which can be very volatile, like a Bitcoin maybe. So which can be, the industry can be very, very volatile. So how does the shipbuilding happen from beginning to the end? First, we build a contract. Of course, before the contract, there are so many other things which are not relevant here. Like before you sign a contract with the shipyard, you have tenders have been made, and then you make LOIs with shipyards. Then you compare the prices of shipyard, and okay, finally I selected one shipyard. Then I make a contract. That is my first step. So after the contract, then I have to start design. So then I start the design. Then what? Then it's the procurement. Of course, once the design is finished, I have to order all the equipments required for me. I have to order all the steel. I have to order everything. Then once everything is in place, then we have the production and then delivery. Very simple, right? So what do we do in the contract stage? The contract stage actually defines R&R, role and responsibility for each party. It will tell you, this is my scope, this is your scope. And common goal is what? To have a good ship and return on investment. And there is a conflict of interest here. For the shipyard, they want to build a not so bad ship with a less cost. But for the owner, he always, for the less cost to the shipyard. But owner always want the high quality vessels. But then the builder want to have a high price for the vessels. But the buyer want to have higher quality with a lesser price. There is always a conflict of interest in the contract. Now the contract consists of shipbuilding contract, we call the SBC, it's an agreement. And it also have many terms and conditions. It will have a role and responsibility, it will have laws, the insurance, and so many other legal things in that. Then important for us is the specification. Important for us engineers or naval architects, it's a specification, which is a technical specification. Will tell you how the ship is to be made and what are the equipment's capacity. Everything else, everything will be described in the specification. Then on top of that, we have the class requirement. Of course, if we have a class notation, then we have the class requirement. It's also part of the contract. Then the domestic and international regulations. And another important part is the make a list. So make a list is like, for example, if you want to have a main engine, you can have Hyundai main engine, you can have main engine from STX, you can have HSG. So how do you select this? At the contract stage, it is very difficult to finalize which maker we will be using for the design. So what we do is for each equipment, we make a list with 2 or 3 options. So for example, in main engine, we will have option of HSG, STX, Hyundai, like that. Why? There's 2 reasons. One is when the shipyard want to have negotiation with the maker for the price. If there is no competitor, the price will be very high. So that is one primary reason where we want to have this maker list. Secondly, there will be some makers which the owner want to put in, and some maker yard want to put in, but there's no time for such detailed discussions during the contract period. It will only lead to arguments and counter arguments. So put it in the maker list, and then we will decide during the design period. That's why the maker list is also part of the contract. Now, if you go to design, there are so many different kinds of design. There's a concept design, there's a basic design, there's a functional design, and then finally you have the production design. So to be sure, I just want to tell you, Korean shipyards do all this by themselves, from concept to production. I know some shipyards around the world, they do only the production design, and concept design and basic designs are outsources. But in Korea, the shipyards do from the concept design until the production drawings. So in concept design, you are only fixing the main dimensions, hull coefficients, volumes, blah, 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 things like that. And then we move to the basic design. This is where we develop the system. Main propulsion plant, electric plant, everything is decided, and based on that we make the key plans. We call the key plans lines, midship sections, general arrangement, system drawings, and deck house arrangement. This is prepared. I think I'm not fully sure, but by the time you pass out from here, from the department, you will be doing concept plus a bit of basic, not 100% of basic, but I think you will be doing maybe 80% of basic design as well. But other things you won't be doing during your career, that you will get to see only when you're working with the shipyard. So once this is developed, then we go to the functional drawing. So that is where the systems are finalized. Equipment selection is done here. So while moving from concept design to the functional design, you have time to finalize your maker list. So by the time the functional design is finished, your maker list also will be frozen. You cannot change anything more. And finally, we have the production drawing, all the details and everything. So until the functional drawing, you will have also the approval from both the client as well as the class. Once those approvals are completed, then the yard can make the production drawing. So how to make sure that all the comments in the functional drawing has been reflected in the production drawing? Most of the shipyards in Korea, they have an online system where only the final drawing can be seen by the production people. And now they have developed the 3D model design. So now there are no 2D drawings. From beginning, the modeling is done in 3D. So from that, you can take the 2D version to give to the production people. Or production people can see the 3D drawings as well as the 2D drawings extracted from it. So then we finish the design phase. So after signing the contract, in general, it will take a year, 1 year to finish from concept drawing to the production drawings. So now I have put procurement and production together. Why? It is because of that. Once design is finished, the designer work is not finished. He has to issue purchase order specification. Normally, it goes to the procurement. Procurement team uses this POS, and then they send to various makers. Makers will come back, okay, we can do this, we cannot do this, this is the price, this is blah, blah, blah. And then this process is also takes some while. It goes up and down, and then the client says, no, this maker is not good. This is, sometimes client have also under the table dealings with the maker. So this is also where the shipyard can make money, because I will give you an example. You have different paint makers, for example. You have IPK, you have Jotun, you have KCC. Suppose for us, the shipyard always try to get the cheapest, satisfying the purchase order specification. So say the KCC is the cheapest, but IPK, the owner want to have IPK. So shipyard is entitled to give this extra cost to the owner. So owner is supposed to pay this extra, because shipyard has the right to choose any maker from the maker list. So we have chosen suppose I am the shipyard, I have chosen the cheapest one. If owner want to have the higher one, it's just, they have to pay the extra. It's just like going to a car dealer, and car dealer always give you the basic model, and then you want additional, you have to pay extra. But the problem here is, not only does the shipyard talk to the makers, the owners or the clients also have dealings with the maker, because they have hundreds of ships which are running on IPK. So they will go to IPK, and then they will push the IPK to bring the price down again. So sometimes it is dealt under the table by giving incentives like additional warranty and things like that. Sometimes it's cash rebate and things like that. This is a very interesting as well as complicated process finalizing the maker list. Okay, so at the same time, the designer also issue the detailed production drawings, including the work order and plans and everything. In Korea, if there is a small change in, suppose you're fitting a small motor and you find that, oh, okay, the support, the foundation is not matching. In a normal way, it's common sense to just cut the foundation and then give a feedback to design, but it does not work in that way. The work will be stopped and will go back to the design, and then they have to come up with a new design and new material, and then the work will progress. That is why the Korean shipyards are not good for repair ships. They are very good at new building, if the process is from beginning. But if there is a mistake and if you want to repair, they are most of the time at sea, because they are not used to this kind of reworks. So any project, as a project manager, your effort will be to minimize the mistakes in designs, because the small mistakes in design is actually costing a lot for the shipyard. We'll talk a little bit more about the procurement. It's, as I said, it's a selection of equipment or a material based on the maker list. You cannot always go for the cheapest. There is always a risk, right? Suppose you are going for a Chinese maker, and then you find that by the time because when the equipment come on board and then the time the vessel is delivered, there's a long waiting time. So most of this warranty starts when the equipment is delivered on board. So then it's shipyard responsibility. So if you always go for only the cheapest without considering the quality, then sometimes it will be backfired. So it's always a risk of buying the cheapest one. Another important technology is just-in-time delivery. What is just-in-time delivery? Okay, I am having keel laying today, and maybe my engine room block will go up next week. So just give me, you deliver your main engine only next week. Don't give me 1 month before. That is just-in-time delivery. that is actually saving a lot of cost for the shipyard and also a lot of space, because you are not storing it. It's coming just in time, and then it is lifted by the crane and put on the ship directly. This is also very important. But there are again risks for just-in-time delivery, like you have a situation like a corona right now. So some of the equipments coming from Europe, the vessel cannot come to the port. They have some quarantine requirements, things like that. So there is always a risk, but Korean shipyards always try to have just-in-time delivery, especially for the domestic products. Domestic products always they have only in-time delivery. So now this is flow chart of the production. It's a very simple flow chart, but I want to emphasize certain points on this. So most of the things are same for all the shipyards in the world. The plate is coming, steel plates are coming. It's going to the shop primer shop, and then it's getting primed up, paint, marking. Then you have the cutting. Then you have small assembly or sub-assembly where they make small webs or longes. Then you have middle or large assembly. And then from here, this is what I want to talk. If you see the block there, the pre-outfitting, the block is always inverted. It is upside down. So this is a stage where the pipe working is much convenient, because you're working down, you're not working up. So if you try to do all the outfitting work after the block is gone to the dock or after the block is turned over, it's very difficult because you have to do overhead job. So these are the techniques they used in Korea as well as Japan. I understand that they do as much as pre-outfitting as possible. So once the block is ready, they do the pre-outfittings except cabling. So all the pipes and everything else, you can see the ladder and everything else goes inside. And then you do the painting. You do the painting of the block by protecting the outfitting, and then you do the painting. And after painting, the painting blocks are having another pre-erection, which or we call grand assembly. So we make it two small blocks, we make it into a big block, and then using cranes, we take the big block and put it into the dock. So we reduce the number of dock erections. That means we will make big grand assemblies, and one ship, there will be 6 grand assemblies, and then we put it in the dock, tuck, and then we weld. So we save a lot of time. And then after that, we have launching. So during launching, most of the vessels is show power ready. That means all your switchboard and everything is ready. So immediately when you launch the vessel, you can connect the show power from the shipyard. And all the small equipments and testings can be done using show power during the key outfitting period. Then you do all those testing, and then we reach generator is ready for running. Then the generator is running, and then you can start all the heavy machineries. So then you have, just before going to sea trial, we have something called a mooring trial, sometimes called as engine trial. Just to run an engine at a very slow speed with the mooring ropes tightened to make sure that everything is okay before we go into sea trial. In between this, there's one more important thing, that is the inclining experiment, which of course all of you know what it is. So we do the inclining experiment before we go to the sea trial. And then after the sea trial is successfully completed, we do christening, or we call naming ceremony, and then we deliver the vessel. So this is the total shipbuilding production flow chart. Now you will be wondering how much time it will take. So this is a typical building schedule in Korea. Of course, they're trying to reduce now, much more reduce. So you can add, say, 1 year of design work. So you'll get the total time required from contract to delivery. So the key KL is the key laying, SC is the steel cutting. And from key laying to launching, that the block is the period where you have your vessel inside the dock. Why LNG ships have long time? Because if you see from launching to delivery, there's about 8 months. That is because they are doing the cargo containment system, which they're using Mark III or NO96 in Daewoo for the LNG carriers. And for containers, it's slightly longer than VLCC and Suezmax, because in container you also have additional testing like container loading test. You have to take one container and try to put it inside and see if it is correctly going in. Container loading test, which will take additional 1 month. So otherwise, tanker, bulker, everything, after launching 2 months, vessel is ready for delivery. So now I want to touch an important part here. So this is some indication of giving you the productivities directly into the cost. So if you do some work in the shop, the same work, if you do at the quayside, it will cost you twice. That's what it says, 2.0 and 1.0. What does that mean? That means that as much as work you can do in the pre-stages will save you that much money. That is where this pre-outfitting, which I was talking before, is important, because the earlier you are able to do the piping work, the same piping work, if you want to do it in quayside, it is going to cost you twice. Why? Because the workability is different. And plus, when you're launched and then all your vessels, all the scaffoldings are all out. So if you want to have repair work, you have to either I call them rope man, those people who use the rope and go around and do the work, or you have to install the scaffoldings again, which again will have more paint damages and things like that. So it is always ideal, before you go to the dock, try to finish as much as possible. And if not, before launching, you try to do as much as work as possible. This is the main fundamental of all the Korean shipyards. This is what they try to do for all the vessels. In Samsung, I remember the 14,000 TEU container ship. Even the propeller was installed at the pre-erections, the dock site, before lifted into the dock. Because they are able to do it because they have a lot of data, and they compare and they find out what is the difference in doing in what are the parameters which have been taken into account, and have done it. So these things actually improves the productivity so much. Now I go to the final part, that is the delivery of the ship. Delivery of the ship is, there are, we call final deliverables, the product, the ship itself, of course. And then we have to give the as-built drawing. We have to give the trial data and result, the sea trial data and result, and then trim and stability booklet, preliminary will be given. And then there will be spare parts, then all the certificates and the equipment and system manuals. So thus you start from contract to the delivery of the ship. So here I conclude my presentation. Hope I was clear to all of you.
Thank you. Thank you, sir, for your wonderful session. Actually, we apologize for the inconvenience to sir and all attendees. Someone has actually put a red mark on the screen. And this comes to the end of our webinar section. And before getting into our Q&A section, I would like to say that there is a feedback form available in our chat box. It's present right now here. So I would request everyone to please fill the form, and every feedback is highly appreciated. Thank you, everyone. So next we will be getting into the Q&A section. So anyone have any questions, please feel free to ask.
Am I audible?
Yeah, you are audible.
Sir, my name is Ashwin. I am from the 44th batch. And my question is, sir, there are different ways to in shipbuilding, right? Like ships made as parts and then assembled, or the other way, means which are made together. So which will be more efficient?
I did not get your question fully. You mean ships are always built in parts. You cannot build one nowadays. It is very difficult. I don't think any shipyard is building like old way where you're putting the keel block and making the steels from scratch. I think it's always built in parts. Does that answer your question?
Sir, or is it like I've heard like maybe some ships are completely made in one shipyard, and some are like some parts are made in one and the others in another shipyard.
Okay, that's a good question. Yes, there are. It's not basically a technical problem. Actually, it is more of a political problem. And okay, I had a shipyard in Korea. It's called Hanjin, which their dock size was just big enough only for 4,250 TEU containers. So what they did is, for the bigger vessels, they built half and then they floated it out and took it to another shipyard where they had the floating dock, and then they welded up. That is one instance. Another instance is now, there are boom from the Russian shipbuilding, like you might have, I don't know if you heard about the Zvezda project, which they are building. Also, India also tried to start a similar kind of initiative with the Gale project with Cochin Shipyard, which actually did not work out. The idea behind this is, if I am a Russian and I want to make a ship in Russia, the Russian government will give me a lot of subsidy. It's the same, like if you buy, you are building in India, the Indian government giving you subsidies. But I cannot build the ship here. I don't have the technology to build the ship. So what do? I contract a shipyard in Korea, and then I ask them to be my subcontractor. So you please build me the half of the ship, and then 2 halves I make, and these halves are floated using the tugboat. It is pulled all the way to Russia, and then the Russian dock, they just assemble it. So the Russian shipyard becomes the shipbuilder, and the Korean shipyard becomes a contractor. Another instance also happens is in shipyards like big shipyards like Hyundai and Samsung. They have their subsidiary shipyards in China and Vietnam. So what they do is the easier blocks, like in case of LNG carrier, the cargo hold, the midship section, they build the whole midship section in China. And then they bring it using tugboat, and then they directly dock them. So this is also followed a lot because China cheap labor, so you can get it in a cheaper cost. This kind of construction is happening, yes. Is it what you were asking?
Yes, sir. Thank you.
Yeah, thank you for asking for the question. So anyone else would like to share a question, please? Unmute the mic, sir. And you can also post the question in the chat box, so I will read it for everyone.
If there are no questions, I think
Yes.
either I was very good or really bad.
You are very good. But
Excuse me, sir. Hello. Good evening,
Yes.
sir. Sir, I'm John Dias. I'm from 43rd batch. Sir, my question is, sir, you mentioned about pre-fitting assembly, which is done in Korea and Japan is in upside down way. The blocks are kept upside down. And the piping and everything is done at that time itself. So why do other countries not follow the same way?
It could be many things. Like, first, one thing is you need to have a crane capacity to overturn the block later. It could be that. And for them, you see, the Korea, I told you, the man-hour cost is much higher. But in countries like Malaysia or maybe Vietnam, to that extent, the man-hour cost may not be so higher. So for them, it would be much better to do later because they have less cost on this. But for Korea, the man-hour cost is much higher. So for them, they have to do it as early as possible. So that's why they have this IHOP, Integrated Hull and Outfitting and Painting. IHOP, it was actually started by Japanese, copied by the Koreans, but IHOP is what they do.
Okay, sir. Thank you, sir.
We got a question in the chat box. Mr. Diwalar Rao, they want to ask, how do they deal with the block containing major equipment, which MVDGs? Will there be any production progress before freezing the drawing? I mean, with the tentative design, will there be any design progress?
Okay, this is a good one. Actually, mainly major equipments comes in a typical commercial vessel comes inside the engine room block and the casing block, right? So when the engine room blocks are normally erected not as a big block, it is erected as part by part, so that big equipments like main engine or SCR or things like that, they can go on part by part in the dock. But all the other equipments, when each decks are being installed, during that time, the procurement team and the design team and the production team coordinate in such a way that they have a target delivery date. Okay, this deck is going on top on this day. So the equipments on this deck should be delivered like that. So it is basically done like following the hull progress. In other part of your question is, will there be any production progress before freezing the drawing? Okay, and see, these shipyards have a lot of experience of building similar kind of vessels. So even though the equipment for this project is not frozen, they still have an idea that, okay, this is the thing that is going to come here. The foundation can be like this. So they use that experience to do. And there is something called a misaligned design, which is used a lot in offshore projects as well. That means if you are not able to align because you don't know what is going to, where the support is going to come, but you should have something girder underneath to give the support. But if you're unable to get the data, then you are going to have some kind of a misaligned design. That means it's very simple. The word is misaligned design, but what they actually do is they increase the deck thickness. That's it. So these things are typically done for the chain compressors on the forecastle deck, because the chain compressor is the last thing we align after the anchor and chain and everything goes up. But the block below has been already fabricated. So most of the time it happens that the chain compressor may not be aligned with the underdeck stiffness we have done. So in this case, we have already considered this misaligned design. So we have calculations are made, FEM analysis is made based on this, so it is okay. So such kind of things which you don't have data, you have different options to do. You can have misaligned design, or you can have more stiffness in that area. So this is not a major problem to the Korean shipyards, but main machineries like diesel generator, main engine are fixed initially. Without that, you cannot progress. If you don't know your generator capacity, you're not able to even make your electrical load analysis in the initial. So you have already fixed. So you know your generator capacity. So you know your model. So these major things are already fixed. There is no delay on these things. Does that answer?
I hope it does. Yeah, yes. So we got a next question by Mr. Nishant. It goes like, sir, I have heard that Korean shipbuilding used to produce mini ships with similar design. What is the condition now?
Similar design, if it is the same design, it's called a sister vessel. So, but I think you're not referring to sister vessel, you're referring to similar design. When you make a lines plan, which is the most difficult part to get the lines plan ready. So each of the shipyards here, they have their own lines. Means each shipyard has a different hull form. So when you are trying to make similar ships, they are trying to use the same hull form. So they don't need to repeat all this towing tank test and things like that. That will save a lot of time for them. And now, recently, the trend has been a little bit different because, the shipbuilding prices have been going down. And the Korean shipyard, the Chinese shipyards, all around the world, there is a drought of the orders. So there's not many orders now. So what does that mean? That means that the docks are empty. The docks are empty. There are many docks available. But you need 1 year for design. So even if the docks are available now, even if somebody purchases a new ship, we don't need the dock now. We need it only next year. So this is where we comes as built ship. So suppose owner is coming and I said, owner is telling me, okay, I know you have a dock. Can you give me delivery at this date? Then the shipyard proposes something called as built. That means all the drawings are already approved by the class for another ship owner. They just use the same drawing, no design, and they just start with the production. That is the latest trend used by the shipyards now because of this, especially because of this corona, people are not able to come for meetings and things like that.
I hope it's answered. Does anyone else want to ask any questions?
Hello, sir. Is it audible? Hello.
Yeah, it's
Yes,
audible.
it's audible.
Sir, how they manage to do with the different class rules, sir? If the shipyard is good at particular rule, if one is preferring another rule, how they manage that, sir?
Okay. During the contract stage, the buyer has option to select a classification society. But almost all major shipyards in Korea, they don't prefer one specific class. They always have, if there is DNV, Lloyd and ABS, they always try to give 30%, 30%, 30% orders to them. Because shipyard has a big say when the contract is signed. They can actually push for the class. So always they try to keep, they don't give monopoly to any of the class. They always try to keep separately. Plus, in Korea, the shipyards are slightly stronger negotiation power with the class. And when I was working in shipyard, I had meetings with the class telling them that, see, TNV class says that, why your class is saying like this? Just accept as it is. So shipyards in Korea are much more stronger in that way, because every class rule, it always have a star mark and says unless proved otherwise. So because all the class rules are basically made based on tankers long time ago. Now we have FEM analysis, we have advanced tools, we can take case by case study, and then we can get approval for everything. So class is not a criteria at all. And most of the rules now, they are become common rules. Like you have common structure rules for tankers, common structure rules for bulk carriers, things like that. So there are no big differences now between different classes. Classes also, they have to survive commercially. So they also try to make the same standard. So it is not a big deal for the shipyards to switch from one class to another. Of course, if you have an as-built design in ABS and you want to have an as-built design vessel in DNV, then there's a bit of work to be done. So generally what is done, easiest way is deliver the vessel as ABS. And then once the vessel is delivered, it is much easy to change the class. Class is much more flexible when you are changing the class after delivery, because it's already accepted by one class. So they will not go and tell that, no, your thickness need to be 2 millimeter more because my rule says like that. They cannot say because it's already delivered.
Yes, sir. Thank you, sir.
Okay, anyone else want to ask any questions? Yeah, so we have some questions here in the chat box. So one question is, are shipyards or shipbuilding heavily subsidized by the government in Korea? Is there another reason for the thriving shipbuilding industry in Korea compared to the other countries?
Yes and no. It is subsidized, but it is not the reason for their thriving more than other countries. It's because of the productivity. The productivity rate is much higher and on-time delivery. If I have a, as I showed in this slide, is on the upstream, you have the charterers waiting for our vessel. So if you promise them, I will deliver on 1st January, then you have to give the vessel on 1st January. So one is their, if they're keeping the delivery date, otherwise is the productivity, and third one is the quality. These are the main thing. Of course, subsidy helps, but that's not the only reason. IIT Madras has come up with 3D printing for buildings. Is it appropriate for shipbuilding? Why not? Why not? It can be used. Shipbuilding is like you are building a house, right? So this is like a house. It has everything. If you go into the deck house or accommodation inside, you have everything. You can use 3D printing to make a lot of supports and things for whatever you want. It can be used. But saying that, I also want to say that shipbuilding basically is a traditional industry. So people are very traditional and they don't like too much of changes in general. So it is a little bit stubborn to new technology. But still we are taking thinking news of autonomous ships and green ships and things like that. But yeah, its small answer is yes, it can be used. The 3D printing can be used for many things, yes.
So we got another question, and that is, any key regions that Indian shipyards must improve?
I think there are a lot of CSL guys listening. I thought they were here, so maybe they will be in a better position to answer that one. Because I have, to be honest, I have never worked in Indian shipyard. Only interaction I have with Indian shipyard is the Cochin shipyard guys who had come to Samsung for a few times when we were discussing the Gale project. So then we could compare a little bit of notes, what is happening in Cochin shipyard and how we can improve to come in Samsung shipyard, yes. But I think one of the CSL guys may be in a better position to tell that.
Thank you, sir. I hope it answered the question. Any more else question? Any more question? You can just put in the chat box or unmute yourself and ask the question.
See, for students, you can ask anything, because you can not only relate it to this, you can ask what happens about any questions you have about your career or how to go about. Any questions you can ask. No need to limit to this presentation.
So there is a question by Mr. Deep Singh, and it goes, how is VR and AR being used there?
Not yet in ships, but it is being used a lot for presentations. Like if you, for example, if we, if you have this HSC, we have a health and safety department. They have their induction training. So induction training can be fire or fall from height, things like that. This is being done in VR. So you are actually using VR, and you are walking through the scaffoldings and things like that, and suddenly fire starts, and how you behave. It's some people say it's like a game. Will you escape or you die? But this is the practical use there. And then commercially, it is very much used, because when clients visit shipyards like Samsung, they have some kind of a marine tech plaza. It is like an exhibition hall where you go inside, and there you have this AR wheelhouse, so you can actually drive the ship. You have all the controls there, and using this augmented reality, you can actually decrease the speed, and you can see how your vessel behaves on rough seas and things like that. Is that enough, Deepak?
So there's another question by Mr. Praveen. And what software is used for the approval of designs? If design approval is done based on 3D models, will the ship owner and class need to have the same software with them?
No, they don't need. The ship owner and class being given PDF drawings. Nowadays, they are not even hard copy drawings, PDF drawings. 3D model, they are in some shipyard, they are using Tribon. In Samsung, they have developed their own software called GSCAD. So both of them, when we send the drawings to owner and class, this is always 2D drawings in PDF format. But we do something called a 3D model review. That is, at the end of the design period, we invite the client to the shipyard, and then in our shipyard or in our 3D facility, we actually show the ship full. So he can actually walk around the ship, and if he has some changes, like for example, he want to relocate this shelf to another place, or maybe this valve is a little bit increased the height, I cannot operate it properly. These things can be taken care before the steel cutting. So just before the steel cutting, when the design is frozen, there is something called a 3D model review.
There is next question by Mr. Nishan. What are the career chances in Korea?
Because of the recent COVID and recession in the shipbuilding, shipyards are not the #1 preferred job in Korea. You know, in Korea, every nook and corner, you have universities with naval architecture. There are a lot of naval architects coming out. And a few years back, it was one of the place where everybody wanted to join. So nowadays, you cannot get young people interested to join the shipyards. The shipbuilding has actually lost its shine in Korea. That said, expats are always part of this Korean shipyards. They need, because their weakness is English. So expats are always needed. So they cannot completely avoid expats. And you can join class. Plus, if you join any class, most of the shipbuilding is happening here. So there is always a chance that you will be dispatched to Korea. You can join some clients. Then clients, if the new buildings are here, then you can. So there are many ways you can be here. There are a lot of seniors here Now very few, but at the peak time we had about 20 people here in Korea in different places.
The next question is, does Korean language is important to get a job in Korea?
Not to get a job, but to survive. Korean language is it's helpful. I can speak Korean language now, so that actually helps me when I deal with production people. And also, when you speak their language, they show more respect to us. Indians are respected because of IT and Buddhism, but if you speak their language, then you get more respect. But it's not a must thing to have.
Thank you. Any more questions? Feel free to put in the chat box or to send me if you want to speak. I hope that's it. In 2 seconds, I hope we can conclude the Q&A section. So before ending the Q&A section, I have a question, that is, you have talked about the VR and AR section. So how accurate is it in implementing this right now? Is it actually a real life situation, or we are still ahead in time?
No, it's quite accurate. It's actually virtual reality, right? It's quite accurate, but I don't understand the relevance of your question, because this is now used only as a training tool. So what we are developing now is, you take a scanner, like it is already in, I think in the offshore projects, they're already using it. You have 3D scanners, you scan the vessel, and then you can actually, how to say, check whether your drawing and the actual installation is matching using the 3D tools. These things are already implemented in some of the offshore projects, because this costs a lot of money, and shipbuilding is very fast compared to offshore projects. So it's not until now worth to use this for a whole projects. For offshore, they have started to use this.
So we got a question from YouTube, and that is, do Korean shipyards manage cost control on an individual project basis? Or meaning to say, at the end of a project, does the yard have an accurate figure of the cost incurred for the project?
Yes, they have. When they start the signing of the contract, then they give a figure of what is the cost compared to the actual. So either it is -3% or +10%, that figure will come down to the project management team. And then if it is a -3% contract, then it is the job of the project manager and the shipyard to, by the time the vessel is delivered, to make that minus into plus. So after the vessel is delivered, there is a calculation by the finance team which tells whether it was a positive or a negative in the end. This also includes the budget we set aside for the AS claims. So yes, we do. We get accurate. Yes.
Thank you. I hope it's the end of the question Q&A section. So I guess.
Morning, Pramod.
Hi, Jatish.
Hey, good to see you after a long time. I think it was a very good presentation from your side, and happy to hear a lot of experience covered from Korean side. Yeah, that was very nice, and it's good to share those experience with our team. That was great from your side. And another thing, I think maybe there was a question from one person, I think, about what all things we can improve in Indian yards. I think you have touched Indian yards. You have touched on that also. Basically, we are lacking on the ancillary industries. That is a very major thing we lack here, especially in India. The time taking for procurement is very high. And for finalizing the design, maybe it takes time. If you see the cost and time required for the same ship, if you construct here and maybe in Korea, that is too much different, maybe because of the availability of data and the ancillary industry, supporting industries we don't have. That is one thing. And maybe one thing you could share is the team spirit and team building events, what happens in Samsung and Korean yards. That I think that is one of the things which helps in Koreans to move faster and forward, right?
Yeah, thanks, Jatish. But the thing's a little bit different from the time you were working here. Actually, then the difference was that, like you said, the team spirit, and always in Korean shipyards, there is no difference between personal life and office life. Whoever is in office is your friend. So whoever is your friend is working together with you. So that bonding is always there. So, and you spend, after your work, you spend your time with them, and that actually makes a good bonding. And another thing which was important for them is, suppose a problem happens. Suppose you want to deliver the vessel tomorrow, and then you find that, okay, something is wrong and this pipe has to be replaced, or things like that. The first thing they do is how to solve. Then they talk about who made the mistakes. So that way they are proactive, and they do the work first. And then, of course, after finish, they found out who has made this mistake, whether the designer has done or what was procurement mistakes and things like that. But unfortunately, with the younger generation coming now, I can see a shift from that. Nobody want to take responsibility. Everybody want to, find out who the actual culprit is before starting to that kind of attitude is slowly coming, but still that team spirit, yes, still exists. And talking about the ancillary industry, I just want to highlight one thing. Maybe Indian shipyards can have a look onto that. The Korean shipyards really try to always help the domestic makers. Like, for example, when they started LNG carriers, there were not enough domestic vendors who were able to make this insulation and IP panels and things like that. But the shipyards, all the shipyards together, they help and develop and bring up industries like Hanguk Carbon. Now they have been supplying worldwide, I think. The difference is, like Jatish said, if you have a problem, if you have a local vendor, you can just call him and he comes and he does the AS. And if you don't have a local vendor, you have to call Wärtsilä, or you have to call Sweden, or you have to call Denmark. These guys will say, no, today is Saturday, I don't work. Okay, now Corona, how I can travel? This kind of problem is there. In Korea, work is first and then family. In Europe, it's totally different. I'm not telling one is right and one is wrong. This is what it is. So for shipbuilding industry, it's a group work. It's not an individual work like an IT industries or things like that. So you need quick action at most of the time. So these small matters actually matters a lot for shipbuilding industry. And our people attitude has to change as well. You have to work hard. You should not consider the blue collar job as something which is below, and they should also feel the, I don't know how to say.
Thank you. Yeah, I think.
Thank you.
Hey, Jadish, this is Sojan Anthony. Question to you, Jadish, not to the presenter. What kind of ancillary industries are you talking about? Cochin Shipyard was established when, and how many years you need to develop an ancillary industry?
Sojan, yeah, it is to me. Good. Yeah,
Yes,
ancillary industries include so many things. If you see, Hyundai has got their own engines, lifeboats, then Korean the painting systems. So these things developing within, if we are able to develop an ecosystem around that is what I was telling.
Yep. How many years you need to develop that kind of an ecosystem?
Yeah, that is true. That is not only, it is a problem of not only Cochin Shipyard, it is problem of our system itself, country, Kerala. You know, if you go to border of Kerala, there are a lot of, Coimbatore has got a lot of industries, but not in Kerala. Why is it?
Do you have to worry whether your ancillary industry is in Coimbatore? For a shipyard like Cochin Shipyard, does it matter whether the ancillary industry is in Coimbatore?
Yeah. I think this is coming up. The culture is changing. A lot of vendor development programs are happening now. I think we have to share this experience, including you. I think people who are working outside. I think now Pramod has shared his experience. We have shared. So what we have seen outside, I think we should share. I think including you, I think you also have a lot of things to share with the Indian industry, which all of us can build up together.
Yeah, let's talk about the steel. Are Indian steel mills producing the shipbuilding quality steel these days?
Yes. SAIL and SR is producing.
Okay, so that's a big change from the days we started. I remember I was in HSL. Almost all the shipbuilding quality steels used to come from abroad, but I understand that's changing. So change will happen, but it's slow.
Yeah.
Sojan sir, I just want to add a little bit on that. I heard this. I am not sure. I've not worked in CSL. I heard that the shipyard itself has to sort of believe more on the domestic and give them more opportunities to use the products rather than just importing everything from outside. I think it should come from within the culture, within the shipyard itself. They should also help the vendors to develop. They cannot just wait for the vendors to develop themselves.
I don't disagree.
Yeah, this happens in outside also, Pramod. When I was there in Malaysia, if you see the government itself, they have a program called Vendor Development Program. So they insist. Now this Atmanirbhar has come in India. They insist that this, maybe if you have pressure vessels of maybe 20 numbers of pressure vessels, high pressure vessels, that out of that maybe you have to have 4 or 5 given to experienced vendors. Then maybe for this project you have to consider new vendors who has to work with the experienced vendor, and slowly they develop the vendors all around their nearby places, such a way that as Pramod said, if you have any issue, you have got you can just call the vendor, get it corrected. So these kind of things, policies, there are a lot of policies has come up from the government. Now you can see Atmanirbhar has taken up, I think a lot of changes has happened in our system also. So many Indian vendors are being given opportunity. Earlier, L1 will come as being a PSU. The L1 will go to maybe a Chinese make, or those kind of issues were there. So now I think
could you elaborate L1 for people? You may be familiar, but not all people.
L1 is the lowest, the cheapest. H1 is the highest. L1 is the when you go for a bid, and the person who is bidding the lowest cost is called the L1. L1 bidder.
Sojan, I am Neelakandan from 8th batch working in Cochin Shipyard. So I just we know each other, but we have not met So in the university we might have met.
Yeah,
So
yeah, we have met that.
I just highlight certain points, that is the vendor development and the ancillary industries. See, in Cochin Shipyard is a government sector, and we can definitely promote vendors. And the point is, we can give certain vendor development program. We can ask vendors certain their requirement, and we can suggest which are the products we require, the standard products. But there are 2 points. When we tell them to manufacture, we cannot give them guarantee that we will buy from them itself. That is this L1 business. That is this. When the L1 business comes, we cannot say that we are guaranteeing you per year this much quantity we can procure from you. That we cannot guarantee. Second thing is the order for the shipyard. If we have the order, we can definitely give certain thing. Out of the L1, we may be able to award certain quantity to them. But suppose we are not having the order, we may not be able to support them. So these 2 things are the main key points in developing ancillaries for Cochin Shipyard in and around Cochin. But I think this is generally there in India also, because the Indian shipyard, if you take together, how many ships altogether we are making, and what is the interest of a supplier to make an industry in India, at least in Mumbai or in Cochin or somewhere, because whether they are able to give the product within India itself. The third point, this Atmanirbhar and everything, we can definitely, being in government sector also, when a foreign order comes and Indian order comes, the Indian buyer will have a purchase priority. So he can be awarded. So this point is already there. So that can definitely support it. The fourth point is, when Indian suppliers, when they do this point, manufacture this, and when they sell it to government sector, they know all the government rules and regulations, and they wanted to take fish out of the water. So there is something they will try to squeeze it to their advantage only. Suppose another party court or something, they dilly-dally this thing, they will try to get the order for them, and the level of the certain Indian parties are not, I'm not telling all, not having that professionalism in their own work culture and the quality level, so that will hit us very badly. So these are the background or scenario within which we are facing the issues on for procuring from Indian ancillaries. I hope I have generally given a brief.
Just I want to add one point here, because in Korea we are taking the heat exchangers from India. There are many vendors in India who are supplying heat exchangers to Korean shipyards. So the whole Indian ancillary system is not bad. We are still using some of them. I know heat exchanger because I was directly involved in that. And some of the Indian vendors are actually sending this the parts of this ancillaries to Europe, and then from Europe it is coming back to Korea also. So India is very much part of this chain, actually, more than what we can imagine.
Yeah, you are right. We are also aware about the heat exchanger. Another exciting fact I wanted to say that actually around 10 to 15 years before, I went to Coimbatore. I went to a valve manufacturing company, and they were making valves and they are exporting to Germany. But when we asked them to quote for Cochin Shipyard, they are not interested. This is the issue. You are being considered. Certain parties are not interested also. So both are contributing to our issues, struggles in the shipbuilding.
Neelakandan, this is Sojan.
Yeah,
so,
please.
Do you mind telling us why they were not interested? Is it because of patents, or is it because of cost, or is it because of reluctance to deal with a government entity?
No, that was not that. They were supplying to a branded, I think, I am not aware, a famous valve manufacturer brand. They have an agreement, so they are only giving to them. and they cannot give directly do, but they were interested. They came to our yard, and we also went and visited this thing. It was perfectly all right, no issue about it. It was very near also, Coimbatore also. Whatever walls we were manufacturing, we are doing it. But still, they were not ready. We struggled. We tried our level best to do. I was in that design department at that time. I tried our level best, but they were not got it. That's all. And they were not able to reveal the fact also why they are not got it. Maybe they're on trade.
There might be confidentiality agreements or
maybe.
Yeah. Neelakandan, I think we have met. I'm from the 13th batch.
Yeah. 18th.
Yeah.
Oh, okay. I was in 8th batch. Okay. Right.
Yes, we have met at Cochin Shipyard and somewhere else also.
Yeah.
I have a question from Kevin. Sorry to divert back to this from that topic. I got heard that after new IMO regulation, works related to ballast water treatment system and exhaust gas scrubbers have picked up in place in China. My personal opinion is scrubber is crap. This was some kind of hoax made by somebody to make money. Now, a lot of vessels are installing this, but this is not the future. This is not going to work. So IMO has gone in a totally different direction now. So ballast water treatment systems, yes. But from my experience, there is no ballast water treatment systems which are working perfectly also now. So for the namesake, vessels are installing. But scrubbers, no, I don't see a future for scrubbers in the new building, at least. No.
Thank you, sir, for your sharing insights. So I guess this is the end of our Q&A section, and I thank every alumni members for sharing their experience from all over the world. And it's always been a wonderful experience for students, especially. So before ending this section, I would like to really thank Pramod sir for taking his time and giving us a wonderful seminar on this topic. And on
my pleasure. Thank you.
Yes, on behalf of SNAS, we would like to present a token of gratitude for being with us in all of the departmental activities. And the token of gratitude will be on your screen.
Thank you. Thank you very much.
Yes, so this comes to the end of our 4th episode of SNAS webinar. And I hope you all have enjoyed the webinar. On behalf of SNAS, I would like to express my sincere gratitude to Mr. Pramod Chambath for taking time from his valuable schedule and making this a very informative webinar on this special topic. I'm deeply thankful to those staff office bearers for helping us conduct this informative webinar. On this occasion, I would like to thank Professor Dr. A. Madhyagan, Head of the Department, for being a constant inspiration, and Anup Sasna's Faculty Advisor for being with us in all the activities. Last but not the least, I would like to thank every faculties and students who put a sincere effort to attend the webinar and make it a grand success. Thank you everyone for the overwhelming responses to our webinar. We apologize to those who couldn't attend this because of the participant limitation. We will get into this in the account, and we will make necessary changes. We expect this support and encouragement in all the future endeavors as well. And yes, this is the 4th episode, and more is always storing for you. And always feel free to contact us and give us the feedback. It's highly appreciated. I would like to say that our 4th episode has been concluded. Now you may please leave the meeting. Thank you, everyone. Have a great day.